This is notes 5.1, and we're going to call this section of notes atomic orbitals. This is 5.1. Do this in your notebook. Do this set of notes in your notebook, okay? 5.1. And you can draw a diagram similar to this. You're going to probably be drawing several of them, so make sure you give yourself plenty of paper. And let's go ahead and look first on the periodic table. And like we've said in the past here, the atomic number here tells you the number of protons. But as you now know, the number of protons in a neutral atom equals the same number of electrons. In other words, the charges cancel each other out. And the function of the atomic orbitals is to tell you what the configuration of the electrons is. Okay, and we're going to get into what all that means in just a moment. Here's how I like to think about it. I like to, well, let's start by looking at a simple example, maybe the simplest example. Let's start by looking at helium. Helium's got its atomic number 2, so it's got 2 protons, it's got 2 electrons. Okay, and what the orbitals tells you is where to place these electrons. And here's how I like to think about it. I like to think about it as the nucleus being down here, and that says helium. I'm going to write helium, and I'm going to write 2 electrons, like so. And the way I like to think about it is the center of the diagram here, of the model, is a stage. And you're going to a concert, and the idea is that there are seats closest to the stage that fill up first, and then the next, after the front row fills up, the next row is the most desirable row, and so on and so forth. So in the case of helium, it's very simple. You would just write 2. The first row's got 2 seats, and in helium's case, these 2 seats fill up with electrons very quickly. Okay, so that's helium. You may want to go ahead and do that and now do a separate diagram in your notebook. I'm just going to erase this, but you'll want to do a separate diagram. Okay, so after these first two seats are filled up, then people have to go to the next row, right? So the next row has got a total of 8 empty seats. There's 4, 5, 6, 7, 8 empty seats, and these seats are going to fill up in order. Okay, so let's pick, for example, fluorine. Fluorine is, it's got 9 total electrons. Okay, it's atomic number 9. So fluorine is atomic number 9, and it's got 9 electrons. So the first 2 electrons fill up in the first row, 1, 2. Now we've got to fill in 9 for a grand total of 9. Okay, we've got to fill in for a grand total of 9. So let's do that. 1, 2. So that means we've got to fill in 7 more. 3, 4, 5, 6, 7, 8, 9. And as you can see here, fluorine now has 1 empty seat. It's got 1 empty seat where an electron could go. All right. Well, let's look at one last example then. That was fluorine, and you might want to go ahead and do a new model here. Let's look at neon. Neon is atomic number 10. Well, if fluorine was 9, neon's 10. That means neon's got 10 electrons. And we've already seen that fluorine has 9. We can count them again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, neon's got 10. So where are we going to place that 10th electron? Right there. Okay. And now the outer row here has been filled up. And if we look on our periodic table, well, first of all, these are called valence electrons. And I'm going to just pause it and get a better sheet to write on. So one moment. Okay, so these outer rows are called valence electrons. They're super important. They're the most important electrons out of all of them, and they're responsible for most chemical reactions, okay? So what we can say is responsible for reactions and bonding. And atoms, atoms don't like or dislike. The atoms are inanimate objects, but atoms like having their outer row, which is a shell, we call it a shell, filled. This equals stability. Okay, an atom that's got all of its outer seats filled is a stable atom. Neon is a very stable atom. It's not going to react. Okay, neon is a gas that's very stable. It doesn't react, as opposed to fluorine, which is a gas that does react, and it reacts violently. Okay, so atoms want to have these outer rows filled, just like just like helium. You can breathe in helium, it's not going to hurt you. And why? Well, it's because the outer row of helium, which as we saw earlier in our first example, it's got just 2 seats, but it's filled up. Okay, so as a result, helium is very unreactive. Okay, hydrogen, on the other hand, if you put if you light it on fire, you know what happens. It's super reactive. Helium will not do that. Okay. So the goal is to have this outer shell filled, and that makes an atom non-reactive. In other words, it equals stability. Okay. So now here's a little trick for you. Well, we can look on the periodic table here, and we said that helium had, well, actually that's a bad example. Let me do 1 or 2 more examples, and then I'll show you a little trick we can do on the periodic table here. Let's go ahead and do let's do carbon for our next example. Let's do carbon for our next example. Okay, next example, carbon looks like this. Carbon is number 6 on the periodic table, so I'm going to write in carbon here. I'm going to write 6 electrons. And again, what I'm going to do is first 2 row, 2 empty seats. Next row, 8 empty seats. Okay. First 2 row fills up with electrons. That's 1, 2, 3, 4, 5, and 6. That's carbon. Okay. And that's got a total of 1, 2, 3, 4 valence electrons. Let's do oxygen now. Here's oxygen. Oxygen on the periodic table is number 8. It's got 8 electrons. Okay, and again, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's do oxygen with 8 electrons total. 1, 2, 3, 4, 5, 6, 7, 8. Notice 2 empty seats here. It doesn't really matter which order you fill these in. I tend to go like that, and you're going to see why later on, but it doesn't really matter the order. Okay, so let's count how many valence electrons it has. 1, 2, 3, 4, 5, and 6. Okay, 6 valence. Ready? Write this in with me. Six valence electrons. Carbon has 1, 2, 3, 4. Okay, and neon, the other example we did, neon's got 8. 8 valence electrons. Alright, so why is that significant? I'm about to show you. If you look on your periodic table, let's look at neon. And let's start counting this row. We're going to skip the transition metals. We're going to count this column. 1, 2, 3, 4, 5, 6, 7, 8. right. Let's look at oxygen next. 1, 2, 3, 4, 5, 6. 6 valence electrons. Let's look at carbon. 1, 2, skip this, 3, 4. 4 valence electrons. Okay, so you can, the periodic table is organized, these rows, I'm sorry, these columns right here. Okay, this says 1, 2, 13, 14, 15, 16, 17, 18. They will tell you the number of valence electrons in, well, at least these atoms right here. Okay, you can count the number of valence electrons very easily, and just remember that, it's going to come in handy. That ends part 1 of the notes.